Hi everyone, this video is about lattice multiplication. This is a really important alternate or non-standard algorithm that every elementary school teacher should know. When you're teaching elementary math, your goal is always for your students to eventually get to the standard algorithm. These are the rules for adding, subtracting, multiplying, or dividing that you were taught in elementary school and maybe even reviewed after that. Those are standard for a reason, and one of the reasons is they are fast. Maybe they aren't the fastest, it depends, but they're the standard in the United States. Students often struggle with these standard algorithms, and part of the reason is that students were never really taught how they work. They were just taught the steps and told, or it was implied, that they just needed to memorize the steps. That doesn't build understanding. It is something that builds math anxiety, and is something that inhibits math fluency. Using alternate algorithms helps some students multiply, add, subtract, or divide in ways that make more sense to them than using the standard algorithm. So you don't necessarily need to teach every student an alternate algorithm. Some of your students will, with your good teaching, learn the standard algorithm just fine. But you as a teacher should be aware of these alternate algorithms. And the most important one for multiplication is the one I'm going to talk about today. I hope you'll learn about these more when you take math methods, but it is something that's covered in math for elementary teachers in the math content course, so this is something you really need to do. And so I'm going to show lattice multiplication. This is what I think is probably the most important of the alternate ones. And it's honestly my favorite. I wish I would have known this when I was an elementary student. So you can do this with any numbers. Let's do a 2-digit by a 2-digit number, and then we'll do a 3-digit by a 2-digit number. So I'm going to do 78 times 49. And I want to know what that is. For the lattice multiplication method, what you do is you write the digits of one number, one factor, along the top, and then you make a grid. And it's important you do lots of space with this. Sometimes when students do this, they don't just give enough space, and it's easy to make mistakes. Then you write the other number along the side. And I would do it like this along the left side. And then you finish off this grid by drawing a line here. And then you just multiply, and then let me rephrase this, then you cut each grid in half diagonally. So I'm blaming my curly lines partially on my mouse, but they would be curly anyway. Ooh, that was a good one. It doesn't matter what order you do these in. 7 times 4 is 28. The tens goes in the top box, and the digits, or the units rather, go in the bottom. 8 times 4 is 32. 8 times 9 is 72. 7 times 9 is 63. So if a student knows their basic math facts, so far this is a really quick algorithm for them to use. And then you add columns diagonally. So you're adding each diagonal column. I'm going to add this diagonal, and then I'm going to add this diagonal, and then this one, and then this one. And I'll add using a different color. So 2, I just have 2. My second diagonal, I have 2 plus 7, that's 9. 9 plus 3 is 12. And then carry the 1. So 1 plus 3 is 4. 4 plus 8 is 12. 12 plus 6 is 18. There's my 8. Carry the 1. 1 plus 2 is 3. So my answer, 78 times 49, is 3,822. We could check this using the standard algorithm. And let's do that, just to make sure I didn't make a mistake. Sometimes I will make a mistake. It's late, I might get a basic fact wrong. That has been known to happen. So let's just do the standard algorithm. 8 times 9 is 72. There's my 2. Carry the 7. 7 times 9 is 63. 63 plus 7 is 70. 8 times 4 is 32, so I go over 1. And then instead of 7, I carry the 3. 7 times 4 is 28. 28 plus 3 is 31. Adding, I get 3,822. So the standard algorithm is quicker. I don't have to draw a grid. But the reason why the standard algorithm is tricky sometimes for kids, especially kids with bad handwriting like me, is because of these carries, right? We're carrying two different numbers to the same spot over time, and they can get confusing. They forget which one they carried, they add something twice, or they forget to add it at all. So a lattice approach can be a really beneficial approach. This was a 2 by 2 multiplication problem. Let's do 3 by 2 as our next one. So 604 times 93. And again, I'm going to pick one number to put on the top. It doesn't really matter which number you put on top, but I would always put the one with more digits on top. So 604 has 3 digits, so I'm going to put that one on top. And then I'm going to draw my columns. And then 93. And I'm going to draw my diagonals. And of course, you could definitely have templates like this already made, ready to go for students, so students don't have to worry about drawing like I'm doing here. That would be entirely appropriate. So again, doesn't matter what order we go in. 6 times 9 is 54. So 0 times 9 is 0. So I'm going to put a 0 in each one of these. It's important that you have students always put a digit in each box. If this were 1 times 9 and the answer were 9, you would still want to put a 0 up here in the top box. So every box has to have a digit in it, or every half of every box has to have a digit in it. 4 times 9 is 36. 4 times 3 is 12. 0 times 3 is 0. 6 times 3 is 18. And then again, I add in the diagonals. Sometimes to help with adding, you might have students extend the diagonal lines out a little bit further so they don't mix up what they're adding together. So 2 is just 2. 6 plus 1 plus 0 is 7. 3 plus 0 plus 0 plus 8 is 11. Carry the 1. 1 plus 4 plus 1 is 6. Then I just have 5. So my answer is 56,172. Let's check this one using a calculator. $604 times 93, 56,172. And then finally, let's do a larger one. Let's do 4 digits times 3 digits. So again, I'm just going to make my grid. Along the top, 3,217. So I have my grid already. I have my numbers already. Now I just need to go and do my multiplication. 3 times 4 is 12. 2 times 4 is 8. And remember, I put a digit in every box. So it's going to be 0 in the tens place, 8 in the units place. 1 times 4 is 4. Again, a digit in each half of the box. 7 times 4 is 28. 3 times 3 is 9, so that is 0, 9. 2 times 3 is 6, that is 0, 6, 0 tens and 1 6. 1 times 3 is 3, we write that as 0, 3 here. 7 times 3 is 21. 7 times 8 is 56. 1 times 8 is 0, 8. 2 times 8 is 16. 3 times 8 is 24. Adding on the diagonals, we have here just 6. Our next diagonal of 1 plus 5, that's 6. 6 plus 8 is 14. Carry the 1. 1 plus 8 is 9. 9 plus 2 is 11. 11 plus 3 is 14. 14 plus 6 is 20. So that's 0 down there, and carry the 2. 2 plus 2 is 4. 4 plus 4 is 8. 8 plus 0 is 8. 8 plus 6 is 14. 14 plus 1 is 15. 15 plus 4 is 19. Carry the 1. 1 plus 0 is 1. Plus 8 is 9. plus 0 is still 9, plus 9 is 18, plus 2 is 20. Carry the 2. 2 plus 0 is 2, plus 2 is 4, plus 0 is still 4, and then 1. So our answer here would be 1,409,046. And I want to say that once more time, and please listen as I say this number. 1,409,046. One thing you didn't hear me say when I said that number was the word and. When we're writing a whole number, or when we're saying a whole number in elementary school math, we don't want to say the word and. And means a decimal point. And we don't use decimal points when we're working with whole numbers. We use them when we're working with decimals. If this answer were 0.3, then we would say 1,409,046 and 3/10. So we only say and if there is a decimal point in our answer. Of course, there isn't here because we're working with whole numbers. Let's once more use a calculator to check this. I had lots of addition there going on in my head, so I might have made a mistake. Hopefully I didn't. 1,409,046. So 3 examples here of lattice multiplication. Again, of all the alternate algorithms, this is the one that is really most often used in elementary school. It is the one that I think is most important for potential elementary teachers to be aware of. The others that are talked about in your book that have shown up in homework, those are also important, but this is, in my opinion, by far the most common. So it's the one that you definitely have to be able to use. I encourage you to set up your own practice problems and then do just like I did with them, and then just check them using your calculator or check them using the standard algorithm to really practice these until you understand it. If you have any questions, please let me know.